Find the general solution to the DEs, which is the differential equation. Now, we are dealing with the first order differential equations. So how do we solve this? Now, we are not looking for exact solutions. We are looking for the general solutions. That means these general solutions, they have what we call the family of curves. All right, they belong to the family of curves. We cannot just have one solution, but they're a family of solutions. This is what we're going to do. All right, so the first one is dy over dx is equal to 2. So how do we work out the first one? So here's what we do. So for the first one, it says dy over dx is equal to 2. First of all, we need to separate the variables. Are we together? We separate the what? The variables. So how do we do that? We can let dy be equal to 2 dx. Once we do this, then we integrate both sides. Of course, we don't need limits, okay? So after integrating, if I integrate dy, I'll just get y. If I integrate 2, okay, I can take out the 2, then I'll remain the what? Dx. So this becomes y is equal to, the integral of dx is just x, by the way. So this just leave me with 2x plus c. The reason why I'm adding c is, look, I don't have limits, right? So I'm supposed to add a constant. And this constant is just going to help us find what in the family of curves. That is what we are trying to do. So if you are told to plot this c can take any form, okay? Any form, by the way. B is asking us to find the general solution to this equation. It is negative x over y. So we are going to use the separation of variables. So dx gets x, dy gets y. Okay. So let dy get y, and x go with dx. So we've separated the variables with their corresponding what? Derivatives. Then we integrate both sides. So the integral of y over d with respect to y itself is just y squared over 2. This negative can come out, then we can integrate that. It's as simple as that. So here we get half, then have y squared is equal to negative 1 over 2x squared plus c. Just like that, then you are done, which you can now collect this. You can leave it like that, there's no problem. I don't want to complicate things, just leave it like that. If you want to can collect the like terms and so on, that's not a problem. All right. C. All right. The c is dy dx is equal to negative y over x. It's different from here because here we're having x, here we're having y on top. We still have to separate the variables. So what I want is this, ladies and gentlemen. Okay, what I want is this dy should have y. What can I do? If I divide throughout by negative y, right? So I'll divide throughout by negative y such that, so by y, I'm going to end up having dy over y. This dx should go here such that this becomes negative dx over x. You see how I have separated the variables? So this x should get dx, then this one should get dy. Then what I'm going to do here is just the issue of what? Integrating. So integrate both sides, and there. We know that this is just the same as the integral of 1 over y with respect to y equal to negative the integral of 1 over x with respect to x. If you know calculus very well, this just give us the natural log of y is equal to minus the natural log of x plus c. As simple as that, which we can now write as the final answer as the natural log of y. We can bring this one the other side, which will just give us plus the natural log of x is equal to c. Just like that. Thank you.